Today we're going to follow up on what we talked about yesterday with compound interest and different money problems, growth and decay, and all those things that are exponential growth. Here is our first little explore and reason. You don't have to write it down. We're just going to kind of go through it and talk about it. Off to the side you can see a vehicle chart. It says years after purchase and then the value of the car. So you should notice, hopefully, that at 0 years it's 10,000, 1 year it's a little bit less, the next year it's a little bit less, and so on. That's the pattern. Cindy is buying a new car and wants to learn how the value of her car will change over time. Insurance actuaries predict the future values of cars using depreciation functions. Depreciation means a decay function. One such function is applied to the car whose declining value is shown at the right. Part A, describe how the value of the car decreases from year to year. Okay, so in this problem, you're just looking to see what's happening between the numbers. So you want to see if there's a pattern. The first thing you should notice is that there's not actually a specific number that shows up each time. So if we did this like our old charts, we would have taken these numbers and listed them out in chart form, yada yada, and then look to see if you're adding or subtracting the same amount. You are not in this case, so it's not linear. If you're adding or subtracting the same amount, you would do that. If it's not linear, last week we talked about checking to see if it's exponential. To check to see if it's exponential, you take the second term and divide it by the first. In that, if it's equal to the third term divided by the first, that means it's going to be exponential. And what happens is if you do this in the calculator, so you will need a calculator today, you end up getting 0.852 each time. Now, when we're looking at our R values, we really only care about that second decimal place. So we can list this as approximately 0.85. So that means it's going to be 85% of its worth from year to year. Okay, so that the pattern actually goes down to only being 85% each year from the year before. If you wanted to model with mathematics what kind of function would explain this, it would be an exponential decay because it's going down each year. If it was going up, it would be an exponential growth. So given your answer to part B, what is needed to find the function the actuary is using? The function can be defined as f of x is equal to the starting value, 10,000, and then whatever your growth or decay rate is, which is what you found, 0.85 raised to the x power. This is what you'll be doing today, but also be using different equations that have compound interest. Here are your two formulas. Feel free to pause right now and just jot those down. This is what we had used last week for pieces that get larger or smaller. A growth meant that the B value was greater than 1, and a decay meant that the B value was between 0 and 1. So like a decimal that's less than 1 or a fraction that's less than 1. Today, you may have to do a little bit of math to come up with that B value. So if you know what your rate is, you would have to either subtract or add from 1. That gives you your number in your parentheses. At any point, you can pause this video. Here's example number 1. The population of Hillville grows at an annual rate of 15%. What will the estimated population of Hillville be in 5 years? So let's write down some important things. The annual rate is 15%. In our problems, we sometimes use percentage and sometimes we may not. The initial population is important. That's on our green sign. The starting population is 5,000. And the question is asking us to find time after 5 years. The first two pieces of information we can use to set up an equation. You have to know what your rate is in terms of a decimal. So 0.15. All we did there was move the decimal over 2 spots. We had to know our initial population, and that gives us enough information to plug into the formula. The formula is f of x, you can use y, is equal to the starting value times 1 plus the growth rate of x. The reason we know that it's plus is because it says it grows. So our starting value was 5,000, and we put a parentheses 1 plus our rate of 0.15, and then we close it out with an x. That gives us our equation, which you can simplify to look like this. Those are the same answers. Now, if you want to figure out the time after 5 years, that just means you plug that into the equation. So 5,000 times 1.15 raised to the x power. That gives us a grand total of 10,056.79. On your assignment, just make sure to check for rounding. So here's just a graphic to help you guys represent compound interest and simple interest. Interest is calculated in 2 ways, simple or compound. Simple interest is interest paid only on the principal. Compound interest is interest that is paid both on the principal and the interest that's already been paid. So you're doing it to 2 things as opposed to just the principal. Principal is the amount of money you have in your account, or that you start with. The compound interest formula is an exponential growth. So you can see from the picture that if you have an investment, $10, and simple interest, it doesn't have as much of a rapid growth, even though it is a growth factor, as the blue quarterly compounded interest. So you want to have a high yield compounding interest account somewhere. Here is your compound interest formula. There's 2 of them. This is the first one. It has all the pieces and all of the words written down. You can hit pause and write that down. And we're going to use this to solve this problem. So this is a certificate of deposit. These are called CDs. You can get these at any bank. We're going to write down some important things. Most of the important stuff is actually on their certificate. The amount deposited, that's the principal amount, is $3,000. The annual interest is 8%, but we're going to change that instead of 8%, 8%, we need to use that as a decimal. That is 0.08. And then the interest is compounded quarterly. That means the end value is 4. We're going to take all of this information and plug it into that giant formula from the previous page. So we've got A is equal to the principal amount, 3,000, times 1 plus our rate, which is 0.08, divided by our end value, which is 4, times, and you may have to type this in as a little caret, that's that, raise it to a power above the 6, parentheses, your end value times t. So the end value was 4, and then t, we didn't say it yet, but t is equal to 5 years. And close your parentheses. Type that in. You can either do Desmos or the calculator. It doesn't matter to me. You can simplify this step if you wanted to. That step alone would give you 1.02, and then 4 times 5, you guys know, is 20. So you can simplify in stages to get you to the right answer. This leaves you with $4,457.84. The next question says, will the value of this CD be greater after 15 years if it is compounded annually versus quarterly? So annually means that the end value is 12, and quarterly meant end value was 4. The time difference here is 15. So pause here, see if you can plug in these numbers and get both the values. Okay, I'm going to do my starting value, so just in case you haven't started yet, this might be a good thing for you to plug in on your own. Let's see, raise this to we're doing 15 years, so quarterly times 15 versus 3,000, 1 plus same interest rate, 12 for annually, raised to the n times 15. Hit pause, type those in. You'd get $9,843.09 versus $9,516.51. So you want to compare those two numbers. This one versus this one. What ends up happening is you have a difference of $326.58. So this one, quarterly, ends up being better than monthly. Okay, we've got a little chart down here. This is about video plays. It has the starting value, and it says it gets at least 1,000 views per day. On the first day, there's 8,192, and then it decreases by 25%. In how many days total will the video stop being a fan favorite? Well, we at least have 3 here, but we could fill out the chart. You can also look at your graph here, so we kind of know that it's going to be more than 6. But we can also build a formula. The formula, f of x, is equal to the starting value times 1 minus the rate raised to the x. The reason it's minus is because it's a decay. It's going down each time. 25% as a rate ends up being 0.25. So if we have her starting value here, and we have 1 minus the rate of 0.25 x, we can use this to kind of summarize the situation. So we'd get 8,192, 1 minus 0.25 is 0.75x. So you can use this to generate the next couple of values, 4, 5, 6, 7, 8, 9. So do some calculations. Plug in different values. You can start with 6, plug it in your calculator real quick, and see what you get out. Once you get an answer, you can kind of show it to me, and then you can start on your assignment.